Okay, how about now? Jim, are you there? Hey, good afternoon, everybody joining us for the webinar. Want to do a quick audio check, see if you can hear us. Great. Thank you for confirming that. What I'm looking for is Jim. We've got a new version of Zoom that has come out, and there's a few new features we're trying to work through, so I appreciate your patience. All right, well, welcome everybody to today's webinar. We are working on getting Jim's screen up and running here. I'm not sure why I'm only seeing myself. Jim, I'm looking for your audio as well. Can you hear me? All right, now we got you, Jim.
Good afternoon, everybody.
Sorry for the technical difficulties, folks, but appreciate your patience. And as Jim is joining us, if those of you who are participating in the webinar, if you could let us know where you are viewing from, always great to see where folks are from and tuning in. Fort Myers, Florida, wonderful. Mount Vernon, Arkansas. Nashville, welcome, welcome, Kai. Butte, Montana. Hey, that's fantastic, Ryan. All right, looks like we're pulling people in from all around the country, so it should be good morning and good afternoon for some of you, I guess. So today, Jim Paden, we're glad to have him with us. He is going to be talking about spoil boards and dedicated fixtures related to CNC manufacturing. For those of you who've not met Jim, I've had the opportunity to work with him for several years now. He brings over 30 years experience working with CNC machines, helping companies really optimize their production, doing everything from service and maintenance to installation. And he's just known as an all-around expert. He's often asked to speak at trade shows on the topics of everything from maintenance to other aspects of CNC. And earlier this year, we had a great webinar just talking about CNC maintenance. And the audience said, hey, we'd like to hear more. And when we asked them what topic they wanted to hear about, they said spoil boards. So when we get towards the end of today, we've got a couple other topics we'd love to get your feedback on. We are scheduled for an hour. Jim has said, and we understand if people need to drop off at the hour, but what we found last time is there were a ton of questions. And Jim graciously stuck around for another hour to answer questions. And so we've got some buffer time in here. We are recording the session. We will be sharing the recording with everybody who has registered. So if you can't stick around for the full thing, you will get that. Jim is also going to be sharing his slides with you. We'll email those out to everybody afterwards. And we've got a bonus we'll include in the email as well, which is his CNC maintenance checklist. So with that, let me get out of the way and turn it over to Jim and say welcome.
All right, ladies and gentlemen, I appreciate you taking a little bit of time to spend with us this afternoon. And while sometimes it may not feel like it, spoil boards can be, uh, sometimes I refer to it as a necessary evil in getting it right, but it doesn't have to be. And there's variables that come along with different types of spoilboard materials and things like that. And we're going to go through those. For some of you, this may be very basic. For some of you, it may be some new things to look at in effective part hold down. So with that said, we'll get into the slides. Any questions as I'm going through this, please do not hesitate to either drop those in the chat. That's what we're here for, is to learn and educate. Okay. So spoilboards and dedicated fixtures, understanding the effects of variables that can make this a challenge. So the first thing we need to look at is,
Jim, we're not yet seeing your slides.
okay. I'm not sure what's going on there.
All right, let me see if I can figure it out. Try it again, see if there's any difference.
Might need to reshare my screen, but I don't see a share button.
It's not down on the bottom.
No, no, sir.
Let me see if I can share from this side then. Pull up your presentation.
I just found sharing of the more screen.
All right, so I'm sharing from my side. Do you want to try from yours, or let me just go with it?
You can go with it. It's fine.
Okay. All right. Just tell me when to move it forward.
Okay. All right. So when we talk about spoil boards, there's several things to take into account in the variables that affect what makes your spoil board work like it does and what can possibly cause issues. We'll go to the next slide. So the first thing is the types of vacuum pumps that are out there. One of the most common pumps that we see is a regenerative blower. It initially has a low cost, but it can be problematic. And that would be the picture in the upper left corner. And then most of you have probably seen the Becker dry vacuum pumps, or a pump similar to that. Those are very effective. It's a good middle of the road type of vacuum pump. And then when we get into liquid ring vacuum pumps, Trevani and Decker, there's some other ones out there as well. That's when we go to like a 25 horsepower or a 40 horsepower vacuum pump. Okay. We'll go to the next slide. So with regenerative blowers, they work well it's initially a low cost type of vacuum pump. The challenges that can be associated with that type of vacuum pump is when you consider how air flows, which is the path of least resistance, and when you make a through cut, that through cut becomes a path of least resistance for airflow. And while the regenerative blowers have a good holding power in it, I'll go ahead and say it, a good sucking power or hold down power, when they begin to move more air through the part, or if you have a part move, that opens up your spoil board. And sometimes the regenerative type blowers can't keep up with that. So we move on to the next vacuum pump, which is a dry vacuum pump, uh, similar to the Beckers. They offer good hold down, and they can move a lot of air through the system. Meaning when you're cutting your parts out, your through cuts that expose the spoil board, the dry Becker type vacuum pumps can keep up with that. When we move to a liquid ring vacuum pump, these pumps offer a superior hold down. However, they use what's called an oil air separator. And what the oil air separator does is the massive amount of air that's moving through a 25 or 40 or even 100 horsepower vacuum pump, the oil air separator cannot keep up with that. And the bigger part of that challenge is you end up with a oil mist coming out of the exhaust of the vacuum pump, and it's kind of a sweet, bitter smell. Uh, a lot of facilities that we work in, they don't mind that. But if you do any kind of finishing work around, if you're spraying paint or lacquer or anything like that, that oil mist can cause a finish issue, just with having that oil mist in the air. Uh, if you're machining cabinet parts, closet parts, doors, your better bet are going to be with the dry vacuum pumps like a Becker or with like a liquid ring vacuum pump. I'm not saying there's any major issues with regenerative blowers other than when you get a open area on your spool board, the regenerative blowers sometimes have trouble keeping up with that open air. All right, next slide, please. So the next variable is the different types of all the MDF doors out there. I'm sorry, of all the different types of MDFs that are out there. 25 years ago, there were only two types of MDF. There was standard grade and there was a single or a double refined MDF. And is the MDF door manufacturers needed a harder, more dense material, that's where it got a little bit more confusing on picking the right type of MDF. So there's a product out there called low or LDF, which is low density fiberboard. In the early days of CNC, we would bolt that down to the machine table, and then we would essentially make like an air hockey table, and that would shuttle the spoil board across that. Uh, Medium density fiberboard, just a standard grade of MDF, 45 pound to 45 to 48 pound density, works extremely well. If we go back to the LDF density, the challenge with that is when we're talking about vacuum hold down on a spool board, you've got to consider what's moving that vacuum through the system, and that's air or the evacuation of air under the part. And as soon as you make a through cut or you're machining holes or outlet cutouts or access panels, that open area is now the path of least resistance for the LDF. And you have a potential of losing a lot of air through the LDF. With the standard grade MDF that's not double refined or triple refined or doesn't have a high resin bond in it, that lets enough air through to hold the part in place, but then it doesn't, you don't lose a lot of air through your cutout of the part. When we talk about high density fiberboard, that could be a good option for a spoil board, but you need to understand that on the HDF, that's going to have a higher refined product in it, meaning that the chips and the dust, it's not the right terms, but the particles they use to make the HDF are more refined. And then there's a high resin content in there, and you may not get enough air through there. I've seen a few posts with some of the groups that I follow where there are some people that are using HDF as their spoil board, and they're getting enough air through it to hold the part in place. So the HDF may be an option, and it may be worth doing a test to see if you can fly cut both sides of it and to see how much air you can actually pull through that board. Are there any questions about LDF, MDF, HDF?
Just curious too, Jim, for those participating, just type in which type of fiberboard you guys usually use for your spoil boards. Is it LDF, MDF, or HDF? Just type it into the chat.
And I know for a lot of CNC operators, this can be a sensitive subject. I used to follow a lot of groups uh, that this subject could actually start a few arguments and a few fights. That's how sensitive it is. So uh, So I see one comment that somebody used to use TruePan LDF. Now they're using just the regular LDF. MDF at Home Depot, Lowe's, that's a good product to use as long as you're getting air through there. Plum Creek's got a good product uh, and just standard MDF. So again, for us, 15, 20 years ago, it was a hard science to describe with the different types of material because all MDF will move air through it. But then we get into the lower density or the MDF lights that are out there that, again, if you follow the path of least resistance for airflow, we saw a lot of opportunities to lose vacuum just by simply cutting the part out. Okay. Appreciate y'all sharing. Next slide, please. So let's talk about vacuum pressure differential. If you don't have a vacuum gauge on your router, which most OEMs are providing vacuum gauges, I would highly encourage you to put a vacuum gauge on your vacuum pump and then also a vacuum gauge on the plumbing going to the vacuum zones under your machine table. So what is vacuum pressure differential? What this is, let's say that with your spoil board down on the machine table, that your vacuum is completely, your table's completely open and you have vacuum. That gauge should read very low. It should read down around 5 pounds of mercury, or Hg. That's the technical term for it. But then when you cover that spoil board with the full sheet of material, you should be pulling upwards of 20 to 25 pounds of pressure. Okay. That means you're holding that part in place with 15 pounds of vacuum pressure. Some things to consider about vacuum and vacuum gauges is absolute perfect vacuum is 30 pounds of mercury or 30 pounds of Hg. Okay. That's absolute perfect at sea level. The higher the altitude, you're going to lose your perfection in vacuum pumps. So if you're in, we've got a few customers in Denver, Colorado area, and we normally pair those machines up with at minimum 40 horsepower vacuum pumps because of the higher altitude, and those customers are being very successful. If you don't have a vacuum gauge on your routers, and I see a lot of OEMs out there that are not putting vacuum gauges on machines, there's not a problem with that. You can pick up an accurate vacuum gauge to put in line for in the $30 to $40 range. And the reason this is important is you have to know how much pressure you have available through the spoil board and what kind of pressure you're creating under the part to hold that part in place. Some things that you can do, good practices, would be painting the edges of your spoil board. Now, we've seen companies with edge banders and they'll run the spoil board through an edge bander. If you're a smaller company, that can become a little bit more difficult because we all know how heavy MDF is. It's not, and then you consider a 4x8, a 5x10, or a 5x12. That's very heavy to get through the edge bander. The other things that we've seen when we edge band the edges of the spoil board is when we surface the table with either a 2-inch or 4-inch diameter fly cutter, that ends up blowing the edge banding off the edges. So as a default, what we recommend is you buy 5 or 6, 10 sheets, however many sheets you can buy at a time. I understand storage can be critical in small facilities. A disposable paint roller in any color of latex paint, wood glue, epoxy. I like latex because most of us have a gallon of latex when we painted the office or we painted the garage or the shop. The color doesn't matter. And we generally we work that disposable paint roller around all the edges once. By the time we get around it, it's ready to go for the second time. And we typically go 3 coats of latex around the edge. Again, there's a lot of different ways of closing that edge up. And what I would encourage you, if you know how to calculate square inches or even square feet, you can calculate, let's say you've got a 10-foot board, 10 foot times 0.75. That's typical thickness of starting for a spoil board. You calculate that open square foot areage around the edge of the spoil board, and that creates almost 2 completely open square feet, if not maybe a little bit more, of open area that you're losing pressure through the edges of the board. The next thing that we would encourage, even if you don't have automated loading or unloading on the machine, would be to bolt the spoil board down. And the reason we do that, initially the reason we did that is we started bolting all of the spoil boards down when we had offload devices, because the offload device sucks all the dust up off the table, and we actually had enough dust collection power that the offload device was picking up and moving the spoil board. So we found plastic bolts. We use an 8mm by 40mm plastic bolt, and that's what we use to bolt the spoil board down. There's other benefits to bolting your spoil board down other than keeping it flat. With the temperature changes coming up, if you're not bolting your boards down, you're going to start to see your spoil boards warp up, and then that's going to allow dust under the edges. And then the dust is going to get into your vacuum pump filters, and then you're going to have a vacuum loss. Okay. So if you don't have a vacuum gauge on your machine, you can Google vacuum gauges, and you need to understand what you have available for vacuum hold down, and then what you can achieve by either sealing the board up or covering up the open areas on the spoil board. All right, next slide, please. So we have to talk about vacuum pump filters, because the majority of the vacuum pumps out there, I've seen a few regenerative blowers that don't have filters in line with them, but we have to talk about filters. And anytime that your vacuum pump filters get plugged up, that is going to restrict the amount of airflow under the table, and that is in turn not going to give you enough pressure to hold the parts in place. So again, these are variables that you have to take into account when you're developing your spoil board. All right, next slide, please. Gunnar, are you there? All right. So the next variable is when you surface your spoil board, it has to be flat. And again, a lot of people kind of take that with a grain of salt. Well, why has it got to be flat? Because some people just don't know, and that's okay if you don't know. If your spoil board's not flat and you put a flat panel down on top of it, that is going to create vacuum loss through the edges of the board, from the surface of the MDF to the surface of the part you're cutting. That's going to create a vacuum loss. So when you fly cut your spoil board, and you really need to fly cut both sides of it, that goes in keeping the spoil board balanced, but you have to open up both sides of the spoil board. In this case, this was kind of a thing that I went through with a customer. They weren't understanding why they were losing parts. Most of the time when we see this, it's because we've had impact from the side of the spindle cutting into the table, and now your head's out of alignment. It may not look like it's out of alignment, but when you talk about a 2-inch or even a 4-inch diameter fly cutter, that compounds. And so the point that I want you to take away from this, if your spoil board looks like vinyl siding where it's got ridges in it, you need to correct the spindle tram or the spindle alignment first, or you're going to struggle with this, or you're going to onion skin everything. If you're not familiar with what onion skinning is, that's the practice of not cutting all the way through. You leave 0.01, a 32nd of an inch, so the parts aren't cut all the way through. Now you're losing production because you should be able to cut all the way through, and now you can't. Some tricks that we've learned in the past. So if we fly cut the length of the table, that's naturally quicker to fly cut the table. Typically it's 2 minutes to fly cut a 5x10, about 3 minutes to fly cut a 5x12. We understand and we look at all possibilities when we fly cut, the customer has to be in operation. So once we know that there's been side impact on the spindle, we can quickly create a program to fly cut across the short axis of the table. And typically that gets us by until we can get the spindle realigned or the customer can realign the spindle. All right, next slide, please. The other thing that will affect how flat your board is it's really important to inspect your fly cutters or your surfacing tools, 2-inch diameter, 4-inch diameter. 2-inch diameter typically will have two replaceable inserts on them. Please keep inserts on hand. They will last a long time, but operators can easily make mistakes. They can chip the inserts. We've seen in cases where they burnt the inserts and now they're cutting with a burnt tool. And the challenge with cutting with a burnt insert is that reseals up the surface of the MDF. Okay. And when you seal that surface back up, because you're essentially burning the surface when you fly cut it with a burnt edge on your inserts, that seals the table back up, and now you're not getting as much air through that table. When you fly cut, this is going to sound strange, the surface of that spoil board should feel a little fuzzy. We don't want to be having a glass smooth finish on the spoil board. It needs to be a little fuzzy, and that fuzz indicates to you that that spoil board is open. Okay, next slide, please. So then we talk about cutting depths and how cutting depths can affect how well your spoil board works. If you look at the picture or the part of the picture that's got the red tool path in it, that was either a tool that was mismeasured or the programmer got the cutting depth the wrong depth. And so when we cut deep into the spoil board, that in turn generates a vacuum loss. Again, we've got to consider vacuum is the movement of air until all the air is gone. And when we have channels in the spoil board, that's going to create a larger vacuum loss. Typically, when we help customers set machines up, we look at setting the max or the cutting depth to be 0.005 to 0.009. You go to a larger diameter cutout tool, that's going to increase the channel and that's going to increase vacuum loss as well. Typically what we're seeing that works well for cutout tools for cutting the parts out would be a 3/8 compression cutter or the 1/2-inch compression cutter. The bigger part I want you guys to take away from this is to be familiar enough with your machine to tune in your cutting depths. I kind of have a strong belief that we should not be going back to programming. If the programmer has consistently created programs with the right cutting depth, we shouldn't have to go back to programming, but we should be able to adjust the cutting depths at the machines. So the bigger part of this, and I'll be honest with you guys, 25 years I'm doing this, I made a mistake on a customer's machine Monday morning, and I cut deep into the board on the first pattern. Accidents happen. And we had to fly cut down, or we actually ended up replacing the spoil board is what we had to do. But there's things there with the cutting depths and simply being familiar enough with your machine on how to adjust those cutting depths. What we like to set up is to have a test, I call it a depth check program. So some of you may have machines that have 8 tools on board. Some of you may have 10 tools on board. Some of you may have 14 or 15 tools on board. And we like to leave test programs behind that either barely cut into the spoil board or they leave, let's say, 1/4 of an inch material behind. So you run a quick test program through all your cuts or through all the tools that you're using. And then you compare, all right, I know that this program said to leave a 1/4 inch thick material behind, and it didn't. So we make that test cut And then we have height offsets on the machines that we can go into and adjust if needed. Okay. So those are things that are very important. We talk about new machines and most of the time they're right, but there's some things that we struggle with. And to have the machine operator have a path to go back and check, all right, well, something's wrong either in programming or in the machine. If we have a test program to make that depth of cut check before we cut into the spoil board, that's of high value to your machine operator. And if you are the machine operator, I would encourage you to have those test depth cuts so that you can quickly tune in your depth of cut. The other thing the test cut does for you is it lets you mic. It gives you an easier way to mic the width of the cutting path. So with the 3-flute cutters, it's very hard to mic and get an accurate reading on a 3-flute cutter. If you're running high tolerances and the part has to be dead on, you have to be able to compensate for the diameter of the tool, either in programming or at the machine. So this depth of cut test that we talk about, that allows the operator to check the diameter of the cut by simply miking the kerf or the router path that was left over. So they can either ensure they're programming with the right diameter tool or they can make the adjustment at the machine. And then it also allows him to check the depth after he fly cuts the table, it lets him check the depth to make sure that his depths are correct. And again, the bigger part of this is to be familiar enough with your machine to tune in your cutting depths. The guys making MDF doors, that's one thing that we see a lot of is they'll spend the time and they'll set it up in the door software, whether it's Cabinet Vision, Mosaic, it doesn't matter what the program is, but being able to tune in all those tool blends. And that's where you have to be familiar with your machine and where you can make the adjustments and where you can't make the adjustments. All right, next slide, please. So when your spoil board is new, the best practice is to make sure that you're fly cutting both sides of the spoil board. The purpose of surfacing both sides of your spoil board is to open the surface up so that we can allow more air to pass through there. You need to have a consideration of the airflow. Vacuum hold down is simply sucking air through a surface until there is no more air to suck. Airflow will follow the path of least resistance. The path of least resistance can simply be the cutout path. When you cut through the part and now you've got a nest of say 20 parts, all that cut through path creates open area. And knowing what you can get away with and knowing what you can't get away with. The bigger part of this is to know the condition of your surfacing tool. No burnt edges and no chipped inserts. Chipped inserts will create the vinyl siding effect and the burnt edges will seize or seal that table surface back up. I'm sure that most of you know this, but as a tidbit on the manufacturing process of MDF. One of the last processes MDF manufacturers do is to sand the panel via inline wide belt sanders. So as the panel's going through the line, as it's getting squished together, coming to final thickness, it goes through a series of sanders. And that sander seals the surface up. And when it does that, you can't let air will not pass through there as easily as if it has not been surfaced yet. Again, this provides a nice finished product, but for spoil boards, that's why you have to surface both sides of it. Are there any questions about when your spoil board is new and what to do with it? Okay, next slide, please. Okay, so now we'll move into talking about dedicated fixtures. There are several ways to create a dedicated fixture. A great resource for CNC router tables and gasket and a variety of different products out there. There's a company called All Star Adhesives. Their website is allstarcnc.com. There's a gentleman there named Mike Murphy. He's done a great job in helping people with vacuum hold down, and he's a great resource for getting gasket material for your machine table. So there's two different types of dedicated fixtures. The first one we'll talk about is called onboard gasketing. And onboard gasketing is, let's say that you've got a 12-inch by 12-inch part that you want to cut. And it's a blank that's already been cut, but maybe it's a hardwood blank. Maybe it's a valance. Maybe it's something out of hardwood that doesn't cover the entire spool board. So some things that we learned in the past is we can take the onboard gasketing, and typically the onboard gasketing is about a 32nd up to a 1/16 of an inch thick. We run an outline of that onboard gasketing around and directly on top of the spool board. And then we can put the part directly on top of that, and you will be surprised if you haven't already tried this, that simple gasket of the material on the MDF will create enough vacuum centralized under that part. And this is one of those things where, and I'm going to go back to, there's a couple of questions in the chat box, and I'm going to come up to that here real quick. If you try this test with onboard gasketing, typically the gasket is a 1/4 of an inch in width. It's about maximum 1/16 inch thick. You put that down on the table, you put the part down on top of that, you will be surprised about how well that holds in place. Okay, so we have a question about how much do we take off of a new spoil board? That's a great question. And typically, I'll take off about 0.01 minimum. And some things to consider, though, is you're fly cutting your new spoil board, depending on how well that spoil board was made. We all know about material thickness variations. At least I think we're all familiar with that. We know that when we buy 3/4 plywood, it's not really 3/4 of an inch thick. It's more like 11/16. Well, MDF can be the same way. So when you fly cut the first side, we typically go 0.01, but after we fly cut that, we do a visual inspection of the spoil board. And if we see any area on that spoil board that has not been touched with the fly cutter, we drop it down another 0.01. Okay. And then we flip it over and we do the same thing. We drop down another 0.01, we surface it. As long as the board's coming out flat, and it's consistently machined across the top of it, that's the bigger part of it. Is we've seen some MDF that's thinner in certain places of the sheet and thicker in certain places of the sheet. So the answer to the question is, at minimum, we take off 0.01 on the first pass. We do a quick visual inspection. If it doesn't look like the fly cutter touched the entire board, we hit it again. And then we flip it over, we suck it down, and then we hit that side. And again, we're making sure that we're opening up the entire surface. You can use methods of taking a pencil. If you're concerned about this, you can take a pencil and you can run pencil scratches all along the board. And if the pencil scratches are still there after you fly cut, you got to hit it again. We've also seen some cases where machine tables have a lower area in them. Okay. And a lot of people don't want to talk about this because it's never a machine issue, but we have in fact run a dial indicator across machine tables and we see dips in the table. It could be the way the machine was built. It could just be the way it's going to be, where you've got a dip in the table, and you've got to allow for that. Because if you consider, if you have a dip in the table, the board's going to suck down into that dip. The problem with that is you fly cut and you use the board, it's going to relax a little bit. And now you're going to have a little void in the spoil board where you can actually bounce on the spoil board. Okay, so Joe King, I'm not sure if I answered your question on that, but at minimum, we take off 0.01. on both sides, and then we start fly cutting. That's if we visually inspect the top of the spoil board to make sure that it's all been machined. That's going to be the bigger part. Okay. The next question was, how deep do we countersink the plastic screws? Okay, typically we use a 8 mm diameter by 40 mm in length. Now, depending on the different varieties of machines out there, that may or may not work. On a 3/4 inch spoil board, we typically counterbore. And the reason we counterbore is most of our customers have a 1/4 inch diameter tool on board. So we can use the same 1/4 inch diameter tool to do the counterbore for the head of the screw to go down into. And then we can machine the 8 mm diameter hole, which comes out to just about 5/16. So when we do that, we typically make the counterbore 0.38 into the surface, and then we do a through hole. The nice thing about MDF is it's pliable enough that when we pull the screw down into it or we thread the screw into it, it gets you just beneath 3/8 of an inch, where the head of the screw is about 3/8 of an inch below the surface of the spoil board. Okay, so I think I answered that question. The next question is, assuming when you pre-bore spoil board for these screws, you do it on the top of the old board. So all right, so that's a great question, Roger. In doing that, typically what the process that we set up is we make the machine drill and counterbore the holes. We make up a program and we leave a program behind for our customers to be able to do this. If you don't have a program to do that, I would encourage you to create a program through your CAD CAM software that will machine those holes. So our typical spoil board replacement is we take the old spoil board off, we put the new spoil board on, we fly cut one side of it. That's our first step. Then we flip the board over and then we run what we call the bolt down program. So the bolt down program machines all the through holes, it machines the counterbores, and then we put the bolts in. And then we fly cut the top side again. Did I answer that question okay, Roger? Great question, because I guess I have kind of a pet peeve that, and I may be reading your comment wrong, Roger, is we should be making the machine drill these bolt down holes and do the countersink. Okay, so the question is, how do we drill through all the way through without damaging the table? Well, you're going to have a hole threaded into the machine table, and that hole is going to be recessed a little bit. And if you're familiar enough with your cutting depths and how to adjust those cutting depths, we use nominal numbers. 3/4 MDF is typically just a touch thicker. So we can program off of that and be accurate enough to allow for a little bit of material deviation. So let's say that you've got a machine table that you've already got holes drilled into, and they're tapped and they're threaded. When you go machine the new holes, you can do one or two things. You can machine the through hole. The counterbore is not going to be the question here. It's the through hole. You should be able to machine to the bottom of the MDF with barely going through it, but not going through deep enough to damage the hole below it, where the threads are at. Does that make sense, Roger? Okay, so I think I got Roger covered. So if you have an aluminum table, you are correct. You are machining into the aluminum. Okay. Most of the CNC routers out there are capable of machining a non-ferrous material, meaning aluminum, brass, copper. And again, once you have those holes machined into the table, Once you machine those holes into the table, you could machine a little counter bore in the aluminum so that when you do machine the through hole, you're not touching your threads. And then James Dickerson, and I happen to know James and Tracy from a company that we do work with, what they do when they replace their spoil boards, and this is a good practice if you have a vacuum gauge on your machine, they machine the spoil board down until they get 5 to 10 pounds of mercury on their vacuum gauges or their vacuum differential. Now that goes to the outer surface of the MDF may be more dense than what the inner surface is. So they're machining down the surface until they get the vacuum reading that they need. And we've seen cases of using HDF, high density fiberboard, or MDF door grade material where it's got a high resin in it. It's got very refined particles in it, where we've had to take that 3/4 inch board almost all the way down to a 1/2 of an inch or 3/8 to even get sufficient airflow through it. Appreciate the comment, James. Okay, so we'll go back to dedicated fixtures. So we're talking about onboard gasketing, which is simply a gasket material that goes on top of your MDF. And this is a great way if you got a valance you need to cut or something in hardwood that's got an odd shape in front of it. You need to understand your programming so that if you're going to use onboard gasketing, you need to know where that gasket needs to be. And so we've developed a thing called trace to place. For a spoil board, we trace the outline of the part with a cutting tool. We put the gasket inside of that cutting tool, then we put the part on top of the gasket. And again, we've held parts as little as 2 inches in width by 20 inches in length directly on the spoil board using what's called onboard gasketing. And again, I can't emphasize enough what a great resource that allstarcnc.com is. They've got a lot of different types of gaskets, a lot of different types of cover sheets, and he's got some very good things in there for gasketing. When we talk about inboard gasketing, inboard gasketing is where you actually have the gasket is typically a 1/4 inch by a 1/4 inch wide, and you have to machine a groove down into whatever substrate you're going to make that dedicated fixture out of. Now, some of this gasketing has a self-adhesive edge to it that once you push it in, it stays stuck. I happen to like the non-adhesive inboard gasketing because I can reuse it. I'm not saying that I'm cheap and I'm tight. That's not what I'm saying. I'm saying if I'm making a flexible fixture that I can adjust the length and the width on, the gasket without the adhesive on it works very well in that case. There's also a product called Square D gasket. It's a 1/4 inch in width and it's about 5/16 tall, and it's got a round top on it. And we'll typically leave that round top out sticking above the surface almost a 1/16 of an inch. So imagine if you've got a countertop that you need to bring back to the machine and that countertop's got a big warp in it. The Square D gasketing will allow it to compress. It will allow it to first seal, but then it will allow it to compress on top of the fixture. So the Square D gasket's a very good product. The other thing that you need to consider when you're making a dedicated fixture is typically the material that you're going to make that fixture out of. It could be plastic. It could be HDF, as long as you don't get any air loss through it. It could be a solid surface type material. When you're talking about a small part, let's say a 1 inch by 1 inch or 2 inch by 2 inch, vacuum sometimes is not strong enough to hold that part in place. You may not be able to peel the part up, but you may be able to push on the part. So we talk about what we call surface friction. So there's products out there that it's basically a rubber coating that rolls down and sticks to your substrate. Then you machine your gasketed area in there. Then you put the gas in that rubber, allows friction under the part, so it's harder to push side to side. You won't peel it up, and you also won't push it side to side if you got friction underneath it, or what we call surface friction. So Onboard and inboard gasketing, both of them serve a purpose. If it's a one-off part, typically we can do a trace to place program where we barely cut into the shape of the part into the MDF, and then we put the gasket to the inside of the cut line, then we put the part down, and then we suck it in place, and we're typically good to go. Next slide, please. So good types of materials to use for dedicated fixtures. Anything non-porous is going to be the best. Plastic, solid surface, acrylic, aluminum, phenolic. Types of materials to avoid when you're making a dedicated fixture. And I'm going to contradict myself here in the next couple of slides. Materials to avoid using for a dedicated fixture would be MDF, because you will lose air through the MDF unless it has a high glue content to it. Plywood, you'll lose air through the layers of, not through the glue line, but through the actual layers of plywood. You'll lose air through that. Basically any material that will not have a vacuum loss. Now, maybe those types of material aren't available. So there's some things you can do if you look ahead a little bit, where you can glue or put a finish on your grooves and your vacuum channels so that you're not losing any air through that. So there's a couple different ways to create surface friction. You can buy an adhesive backed rubber sheet that will cover a 4x8 spoil board. And I'm not talking, it's very similar to the tile gaskets, with the exception it doesn't have the holes in it. So this is called a cover gasket. Some other ways in a pinch, because sometimes we get on jobs and we have to make stuff with what's available in front of us, is an experiment. We used Flex Seal, where we had MDF that we were going to use to make the dedicated fixture out of. We put a couple of heavy coats of Flex Seal on that. The color doesn't matter. And then we surface it. And we surface it until it's all the same consistent thickness. And then we can begin to machine the gasket grooves and the vacuum channels into that. In either of the above cases, after coating, create a program to route the gasket into. So you can either cover, you have to think about how many parts you're going to make if you're going to actually make a dedicated fixture, and what kind of time you want to put into that dedicated fixture. That's the bigger part of it, is how quickly do you need the part, and how much time can you put into it in making the dedicated fixture. Okay, next slide, please.
Jim, I know you've got a couple more slides to go here. Just doing a quick time check. We're about 5 minutes to the hour, and understanding that some people may need to drop off at the top of the hour. Do you want to throw out the quick question on the next topic for webinar so that everybody can participate, and then we'll continue on?
We can do that. Appreciate the reminder on the time. Sometimes I get carried away. So a couple of topics that we've talked about, and one of the topics goes back to exactly what we're talking about good part hold down. And that would be spindle alignment. If anybody would be interested in having a session on spindle alignment, we can look at doing that, or we're also thinking about doing a webinar on cutting tools and proper feeds and speeds. And so those are two topics that we're thinking about. That doesn't mean that that's what we need to do, but those are two topics that we're considering.
Yep. So weigh in the chat. Type 1 for spindle alignment, 2 for cutting tools with your vote. And we'll certainly take that into consideration as we come up with the next webinar topic. And by the way, for those of you who do have to drop off at the top of the hour, just remember we will be sending out a full recording of everything here, and we greatly appreciate your being here today. We also appreciate Diversified Equipment for sponsoring this webinar and allowing Jim to share his knowledge with everybody. And if you have enjoyed the content that he shared with you, by all means, visit the website and drop a review on Google Reviews for us. We'd certainly appreciate that as well. All right, let's carry on with the content then. Thank you guys for voting.
Yeah, appreciate all that. Thank you, gentlemen.
Next slide.
Okay, next slide, please. So when we talk about the different types of dedicated fixtures, if you consider a pod is a dedicated fixture. And if you're not familiar with what a pod is, back in the days we had point-to-point, and we still have point-to-point machines out there. So a pod was something that could be placed anywhere on a rail, and we were able to adapt that same technology in the picture to the upper right-hand or left-hand corner. That's actually a piece of solid surface, two pieces glued together. So that pod was about 1 inch thick. That pod is about 8 inches by 8 inches. And we simply made squares. We used the CNC router to do this. We made squares, and you'll see the vacuum channels in the top of that, and then you'll see the rubber gasket on the outside line. We are very effective to be able to put multiples of those pods under a part and then be able to suck those pods in place. So you can refer to that as a pod or a floating fixture. Okay. And then we've also made what we call a layover pod and rail system to go onto a flat table CNC router. And the company that I actually made this for, it went on top of a spoilboard. The main board has vacuum channels underneath it to channel that vacuum up to underneath the pods. The rails can be slid, and then the pods can be moved in 12 millimeter or about half-inch increments. So those are just two basic examples. While they don't look like a dedicated fixture, that's a very flexible floating dedicated fixture where you put the vacuum where you need it. Okay, next slide, please. So creating a dedicated fixture, it comes down to being all about the airflow. Okay. It kind of goes back to one of my initial statements in spoil boards and dedicated fixtures, and it's all about the airflow. You'll see the channels, the grid in there, and typically a 1 inch by 1 inch grid provides enough vacuum under the part. Typically, we'll use a 1/4 inch down shear cutter, and this is the part where I said don't use plywood for this case, but the part that we were bringing back to the machine, there was not a lot of side pressure being put on it, so I wasn't overly concerned about losing vacuum through the layers of plywood. So in this case, we machine grooves, and the grooves are there for the vacuum to flow through. And then you can't see it in this picture, but there's through holes that go through that to access the MDF beneath it. Okay. The main reason we used a 1/4 inch down shear is so that we wouldn't be tearing the plies of the plywood up, so we would still have a smooth surface. Your outer line that the gasket's actually going to go into, you'll see an outline around that part, and that's where the gasket presses down into. That needs to be as close to the edge of the part as you can get it, but not too close so that the edge of the part is not fraying away. Typically, this was a prototype. If this was going to be continued in use, we would probably make this board out of a phenolic or a solid surface type material. The depth of the gasket, the groove for the gasket to go into, the vacuum channels, the grid that you see in there, at minimum about 1/8 of an inch depth on those. But you need to understand on your outside that's going to create the vacuum seal, that depth is extremely important, because if it goes too deep, now your gasket is beneath the surface. If the gasket sticks up too high, then the perimeter of the part is going to suck down, but the inside may float a little bit, and then now you're chasing a depth issue. So the depth of the cut for the gasket to go, you'll see in this picture that the outer depth doesn't look very deep. That's because I had an 1/8 inch thick self-adhesive gasket that came with the machine that I was sticking down in there. Okay. Right, next slide, please. So this is why we were doing this. The customer needed to be able to horizontally machine a hinge hole into the edge of the part. So this was a prototype mode. or a prototype type dedicated fixture where we were able to machine the hole through the edge of the part. And we needed to make sure it was going to work because we were using an option on the machine that was not made to machine a hole or to machine with a router bit. It was a horizontal drill that we adapted and stuck a router bit into it. I gave the secret away there. I was asked if we could do this. I said, we'll have to try it and see. So we made a quick experiment, and in doing the experiment, we determined that it worked. So the finished part for this customer, next slide, please. So he was machining a plastic part, a plastic door that needed 2 hinge slots in it for a sauce type hinge. And that's, you'll see in the picture that, it looks really thin on the top. That's what it needed to be. It wasn't because we were at the wrong Z height. It's because that's where that hinge needed to land in that door. So we essentially took a nested base CNC router, made a dedicated fixture to go on top of it. Now what we did, can you go back to the previous slide, Gunner? Previous. Sorry about that.
It should be showing now.
No, go to the one before this one.
Okay.
Sorry about that.
That one?
There you go. So you'll see the holes in the corner of this fixture. Okay. So what we did on that, so that we could quickly, and we knew exactly where that piece was going to land on the machine table. Those are simply 8mm through holes. We in turn machined the same set of 8mm holes into his spool board, and we pinned it in place with 8mm dowels. Now, since this project, the customer purchased a hinge machine so that he wouldn't have to tie his router up for doing horizontal hinges, but this is a way or a reason to be able to make a dedicated fixture. Okay, next slide, please. And next, and next. So some notes about creating dedicated fixtures. The number one note is you may fail on your first attempt. I did. And that's how I learned what didn't work. So you have to have the willingness to have the idea. All right, I've got this idea that I need a dedicated fixture. The bigger part of the dedicated fixture is getting flow on top of the fixture and flow on the bottom of the fixture. That's probably the single most important thing I can share with you, because I've done a lot of things in the past and I tried a lot of experiments that didn't work. And so don't be afraid to try this. The next one is you need to know your machine. You need to know how to make cutting depth adjustments, as well as knowing what your part 0 and what your work coordinates are on the machine. The next thing is you need to be very well versed in your CAD CAM software. You don't have to be an expert, but you need to understand offsets, offsetting the gasket in so that you're not cutting through the gasket when you're cutting the shape of the part out. Being able to machine the vacuum channels in there, being able to machine a through hole. You have to be very well versed in your CAD. Again, you don't have to be an expert. You just need to understand, all right, here's the idea. I've got to get vacuum on top of the part. I got to get vacuum under the part. I've got to have a channel for the vacuum to go through, and I've got to have a groove for the gasket, and knowing that you're not going to be cutting through the gasket. The bigger part of dedicated fixtures is once you make your first dedicated fixture, whether it be an onboard fixture where you simply put gasket on top of your spool board, or an inboard fixture where you actually machine a groove for your gasket, you're going to open up new opportunities to take full advantage of your CNC investment. Okay. Any questions about dedicated fixtures? And I think to some, go ahead, Gunnar.
Roger's got a question. If your fixture's made out of solid surface material, does it need to have through holes for the vacuum?
Yes, sir, it does, because the vacuum's got to get to the bottom side of the part. Great question. So if you think about a dedicated fixture in solid surface, for me, is one of the best materials to make a dedicated fixture out of because it is a truly sealed product. You will not get air through that part. Okay. So typically in the early days of solid surface fabrication, CNC routers are very effective use to machine and cut solid surface type material. I'm not talking about granite. I'm not talking about quartz. I'm talking about true solid surface material. You can't pass any air through it. You can actually pass air through granite, and you can actually pass air through a lot of the natural stones out there. With that said, when you machine a fixture with solid surface, you have to machine a grid on the bottom side of it and then a groove around the perimeter for the gasket to go into. But you got to have the vacuum channel in there, and typically 1 inch on center for your vacuum channels will be enough. Then you flip it over. It's going to be two-sided machining because you got to machine both sides. The top side is essentially exactly what the bottom side is. It's got vacuum grooves in it, and it's got a channel in it. So there's two programs, one for the bottom side. You machine the bottom side, you flip it over, and then you machine the top side. And then when you machine your top side, that's where you put your through holes through it. And there's various different ways of through holes. On the machines that we provide, there's a little rubber plug that comes in all of our vacuum tables. And we actually machine the through hole in the counter bore so that rubber plug can be put back down into the pod or the fixture. So maybe I need to channel the vacuum to a smaller area. The only other consideration with using solid surface for a dedicated fixture, and you need to plan for this, okay? Solid surface material has a worse material thickness variation than what plywood does. I've seen solid surface be almost 3/8 on one edge and almost a full 1/2 inch on the other edge. So when we talk about cutting depths, and if we're going to make a dedicated fixture out of solid surface, you have to surface that down to a consistent thickness. Check it with a caliper, mic all your edges. If you're fine with that tolerance, but you need to know what your tolerance is. If it's thin on one end and thick on the other end, you're the only one who can determine if that's going to be an issue or not. But typically when we make pods for solid surface or a dedicated fixture, typically we're doing that to raise the part up off the table so we can do a bullnose on the edge of the part, or we can put a decorative finish, a decorative edge on that for the countertop industry. And that has to cut underneath the part because we always machine good side down when we're doing countertops. So with that said, if your pod or your fixture thickness is not consistent all the way across, you're going to be chasing cutting depth issues. And somebody chimed in on an upcut O-flute for solid surface. I can't tell you how much solid surface we've cut with a 1/4 inch diameter cutter, super O-flute or an upshear. And the solid surface is one of the easiest things to machine out there. It's almost better than machining melamine or MDF.
There was a question above that one too, Jim. Will you need to create a plenum underneath for airflow?
Yes. Yep. So the vacuum plenum, if you're making a dedicated fixture, great question, by the way. You have to have a vacuum plenum. I call it a grid or a matrix. You have to have a vacuum plenum under the fixture, and then you have to have vacuum flow on top of the fixture.
Before we jump to Ryan's question, we've got one in the Q&A section from Linford Martin. It says, where is a good place to buy solid surface material for fixtures, and what's the best solid surface material?
Okay. That's a tough question. And the only reason it's a tough question is I'm not in the business, and please don't take this the wrong way. I'm not in the business of selling solid surface. The best thing that I could tell you to do is check with some of your panel vendors, Worthwood Group, Stixie Plywood, some of the other ones out there. Chances are they have a solid surface product because there's 5 or 6 different major solid surface providers out there. The type of solid surface is you want a high acrylic content. There used to be a product out there, and this is not downgrading the product. It was called EOS. And it had a lot of, I guess what you would say, particulates in it that were not acrylic. And I almost was ready to go to my grave with this. I almost swore that they were sweeping the floor up, putting all the floor sweepings into this mix of product of what they were trying to sell. It's a good product, but it had a lot of particulates in it. And the problem with those particulates are they chip easy. And we found in some cases where it's extremely hard on the cutting tools. So you need a high acrylic content. Corian and LG make probably the most stable solid surface I've seen. As an example, we've done what's called layover tables for the solid surface industry, where we got vacuum ports in there. And we were able to take from LG, we surfaced the entire tape. We basically bolted down a 5 by 12 foot piece of corian. We had to seam it together, but we basically bolted that down to the machine table. This was a 30-foot long machine. We have one side for part reintroduction and then one side for nesting. That's how we set the machine up. And in doing this, when we fly cutted or surfaced the LG product, it did not warp no matter how hot we got it. It didn't warp. So as long as it's got a high acrylic content in it, that's going to be the product to use for your dedicated fixtures. The other thing you need to consider is how thick does the fixture need to be. With that said, if we're starting out with 1/2 inch thick material, we're naturally going to surface both sides of it if we're making a dedicated fixture out of this. And again, I live in the world of absolutes, meaning that I have to know that my thickness is right and consistent across the top of the material. I know there's tolerances, but I'm talking about paper thin tolerances, not a 32nd or a 1/16 of an inch difference. So I kind of live in that world. It has to be right, and we're going to make it right either by surfacing it. You could send it through a wide belt sander, but I have trust issues with wide belt sanders. So I know once I work with the machine, I know where its accuracies are at and where their accuracies are not at. All right, so there's another question from James. Just assume you can't use any of the factory edges on solid surface. Yep. Yep, and it's because when they send it through their sanders, the edges are coming up or they're coming down. Their chances are they're probably not using a vacuum conveyor where they're actually sucking the part down to the vacuum, and that's what causes it. And then heat. Heat will cause corian and solid surface to warp up too. Okay, and then Gregory is commenting that he's got 2 regenerative blowers hooked up in series. For his hold down, I have 2 more blowers that I'm going to hook up. How should those be hooked up? Do I want to add those to my current series? So what I would look at doing on something like that, Gregory, I'm sorry about that. We don't use a lot of regenerative blowers, but I know that they're effective and they work. So consider the movement of air and how much air you can pass through a pipe, because your pipe is what's going to carry that suction through to the bottom of your machine table. So it looks like you're going to have 4 regenerative. You already have 2 and you're looking to add 2 more to the system. So what I would look at doing, and it's not necessarily a gray area, but it's something that you need to consider. I would look at having a valve at the end of your regenerative blower, then that valve goes to a manifold. Let's say 4-inch diameter PVC, okay? And that 4-inch diameter PVC is going to carry that vacuum to the bottom of your table. So you'll plumb whatever you have in plumbing from the bottom of your table to a 4-inch line. The reason I say add that cutoff valve in there is so if you don't want to run one pump, you turn the valve off and then you only run 3 pumps to it. You've got a manifold that all 4 of these pumps are going into. Does that kind of make sense, Gregory? Okay. And again, I'm familiar with regenerative blowers, but it is kind of a gray area. But my first initial thought is make up a manifold at a maybe 4-inch or even 6-inch diameter PVC that those pumps tie into, because you're looking with four of those pumps, you're looking to pull more air through the system. Now you could do 2 and 2. You could tie in another 2 to a manifold that feed the machine separately as well. But I think you may have better luck going 4 into one central manifold. All right. The next question is there any value to having a, yes. So in the early days, I'm not sure if that question is dealing with a regenerative blower or if it's dealing with a standard vacuum pump. Because one thing that I learned about regenerative blowers is they like to always have air moving through them. And if you look at just the most simple definition of vacuum, it's the devoid of material going through something. In this case, the material going through something is air. So we're sucking as much air out. And I actually caught a regenerative blower on fire inside of the regenerative blower. And we were able to quickly disconnect the power, get it outside, and then it cooled down, but it still worked. So regenerative blowers like to suck a little bit of air through the system to keep that system cool, to keep its internal system cool. So if this question is in regards to regenerative blower, I can't give you a good answer on that because I just don't know. But in the old days, we actually had people taking a compressed air tank and using that as a vacuum reservoir. We've had customers that locate their vacuum pumps outside of the building. And when they locate the vacuum pumps outside of the building, that means they had to plumb them in. Well, we had one customer that it was a 100-foot run of 4-inch PVC that he used to connect to the machine and then connect to his pump. If the valving is at the CNC router and not all the way out at the vacuum pumps, that creates a natural reservoir of vacuum, and that seems to work very well. However, on the Becker type vacuum pumps, the challenge with those, when you don't have vacuum activated on your table, on the machines that we provide, it's got what's called a relief valve on the filter. So that if vacuum's not activated on the table, this relief valve opens and it lets air through the system. So where we've seen the bigger effect on having a vacuum reservoir is with the liquid ring type pumps. There's Becker, Trevania, there's Atlas Copco, however they pronounce that. But the valve, in order for that reservoir to take effect, your vacuum valving has to happen at the machine. And then anything from the machine vacuum valves to the vacuum pump, that is now either your natural reservoir of vacuum, or it could be a compressed air tank. I will put the disclaimer in there. Check the condition. If you think that you want to use a compressed air tank, I'm not going to be liable. And I have to say this because I have seen powerful enough vacuum pumps collapse the reservoir. Okay, so you need to make sure that that reservoir is rated for vacuum and not just pressure, because there's a big difference in there. The other disclaimer, not disclaimer, but some other things to keep in account is if you're using PVC, and it's a great material to use for a vacuum line from your vacuum pumps to the routers, you got to make sure you're bolting that spoil board down. Okay, and the reason for that, and I have to talk about this and I have to comment on it. If your spoil board's not bolted down, that means you're getting chips under the spoil board between the machine table and the bottom of the spoil board. And those chips are going to travel through the PVC line. And when those chips travel through the PVC line, you are going to get static discharge. Static discharge could create a fire in your vacuum pump filters. Okay. And I don't want to get into the full-blown discussion because I see a lot of posts where people are using PVC pipe for their ductwork. Now, I know this is not a dust collection conversation. This is a conversation about vacuum, but I've seen firsthand a grounded PVC line literally explode because static was going through it, creating a static discharge. And then it got to the top of the dust collector and the static discharge sat on top of the dust and the guy lost his shop. So I've got to, if we're going to talk about PVC, I'm sorry, but I've got to say that. All right, Ryan, can you repeat your question or retype your question, please? Okay, Ryan, if you could you type in your question again, please? There, I got it now. I got it. What is the best way to drill into the phenolic table? Okay, that's a good question, and I'm glad that you asked that. So typically, on the machines that we provide, we have a pattern of holes that are already there. But we've had several cases. You're absolutely right, Ryan. We've had several cases where we have to machine the holes. Now, you can machine a hole into the phenolic tabletop with a 1/4-inch Super O, and then you can thread that hole. And that's going to work for the first maybe 1 or 2 spoil boards. Using a threaded insert or a helical for the threads to go into, that's going to be your better bet. But typically, if you're machining bolt locations into your phenolic tabletop, it's important that you draw the entire tabletop out, meaning you know in a drawing where all of your vacuum access is at, you know where all your metal bolts are at, because we don't want to be machining into the metal bolts that are already there. Draw that out and then determine what your bolt pattern needs to be. Typically on our bolt pattern, we try not to get the bolts more than say 2 feet apart. 18 inches to 2 feet is the maximum width I want those bolts to be apart. But yes, using a threaded insert or even a simple helical. I guess I'm kind of the old school to where I'm going to tap the hole first into the phenolic. That's going to wear out. Then I'm going to put a threaded insert into it. If I have any issues with the threaded insert, I can then go to a true threaded insert. And the difference between a helical and a threaded insert is a helical is basically a spring that you machine a hole, you tap the hole, then you thread the spring into the hole, and the internal of that spring is the threads for the screw. An actual threaded insert is a round disc of metal that has threads on the outside and threads on the inside. So you machine the hole, you tap the hole, then you thread the threaded insert into that hole, and now you've got internal threads.
Jim, you mentioned the spacing on the bolts. Is there a rule of thumb for how many bolts you would use for a given size of product?
So we just did a machine table recently, about a month ago. It was a 5x12 table, and I want to say that I put 35 or 36 bolts into that. And again, I kind of go by the rule, because some things that you have to consider when you bolt the spoil board down is I kind of use the tap method. When I tap on the spoil board, if I hear hollow spots under the spoil board and I know it's not a vacuum channel, I know that it's not solid to the tabletop. And a couple of reasons why we use so many screws, particularly around the perimeter. Okay, we're looking for no more than 18 inches to 20 inches of spacing between the bolts. With the weather in the southeast, now if your climate stays the same, it's not going to be that big of an issue. But when we consider a 5 foot by 12 foot machine table, after we bolt it down, we actually see where the spoil board can warp up a little bit. And that's where you need to pay attention to good fly cutting of the table or surfacing of the table. And making sure that it is sucked down to the tabletop. So that's a reason why we use so many screws in a tabletop, is to ensure that it stays flat whether the vacuum's activated or not.
And James Dickerson had a comment about PVC.
Okay, so they used 8-inch PVC to create a reservoir, but you have to let the vacuum build up before opening the ports. So I'm very familiar with James's location. I believe they've got a 40 horsepower Atlas Capco pump, but that's plumbed into 2 CNC routers. Okay. And so what James is saying is they can't immediately turn the pump on and then activate the vacuum to the tables. You could call it a vacuum pump warm up, meaning that every CNC router requires a warm up process for the spindle. So the grease lubricates. It's about a 5-minute program. So it's similar to so you could call his vacuum a warm up. He's letting his vacuum run for 5 or 10 minutes before he activates the machine table. Is that accurate, James? I think that's similar to what he's saying.
Right.
Yep. It's less time than that because you're evacuating air out of a sealed area.
All right. Well, it looks like we have come to the end of questions, and I want to say thank you to Jim for sharing all of your expertise out there with folks. And for everybody who joined us today on the webinar, we're grateful to have you here and appreciate your interest and appreciate your voting on the next webinar topic as well. We don't know exactly when that'll be, but we will be sure and contact you since we've got your email address and let you know about any upcoming events that we've got going on. And thanks again to Diversified and Equipment for their sponsorship of this webinar and for supporting Jim and his endeavors and helping him build up his expertise out there. I think that'll wrap it up for today. So thanks so much. And look for our email with Jim's slides and the recordings and all that sort of stuff. We should have that out to you within the next day.
All right. Ladies and
All right.
gentlemen, thank you for
Have a great
attending. I
day.
appreciate it.